Hello and welcome back, dear student, in the next module of the topic solutions. So dear student, in the last lecture we have completed what is mean by solubility, what is the unit of solubility and the factors affecting on solubility. In that, the first factor, that is the nature of solute and solvent. Solubility is the maximum concentration of the solute in its saturated solution. Solubility is the maximum concentration of the solute in its saturated solution. The unit of solubility is mole per dm cube or mole per liter. So for that we must know about the concentration terms. To express the concentration of the solution, we have discussed there are many more terms to express the concentration of the solution: molarity, molality, normality, formality, parts per million, percentage by mass, percentage by volume and a mole fraction. So these are the various terms to express the concentration of the solution. Then the next point is what are the factors affecting on the solubility. In that, the first factor is the nature of solute and solvent. And therefore, dear student, in that we have seen, according to the rule, like dissolve like, a polar solute dissolved in a polar solvent and a non-polar solute dissolved in a non-polar solvent to form a solution. So up to this we have completed in our last lecture. In today's lecture we are going to discuss our next factors, that is the factors affecting on the solubility. The second one is effect of temperature and the third one is effect of pressure on solubility. Let us see one by one. So let us start with the second factor, that is the effect of temperature on the solubility. And for that, here we have considered two beakers. In that, in the first beaker, here we have considered a cold water, and in the second beaker, here we have considered a hot water. And in both the beaker, if we add the same amount of solute means a solid solute. If we add a NaCl or a sugar, these are the solid solute and these are the liquid solvent. And if we add the same amount of solid solute in both the beakers, then which one is soluble faster? Obviously, a solid solute which dissolve early in a hot water than the cold water. So as the temperature increases, the solubility of the solid in a liquid also increases. And therefore student, in our textbook, in figure 2.1, we have given the solubilities of some ionic solids with temperatures. In that, we have given ionic solids such as NaCl, KBr, KCl, NaNO3. All these solid ionic solute, when they dissolve in a water, then as the temperature increases, the solubility of these ionic solid, they get increases with the increase in temperature. But there are some exceptions. For example, Na2SO4, sodium sulfate. Na2SO4, sodium sulfate, the solubility of Na2SO4 decreases with temperature. There are some exceptions for this naturally occurring process. Naturally, as we told or as we know, the solubility of the solid in a liquid increases with increase in a temperature. Temperature means we are deals with the two types of processes, exothermic process and endothermic process. Or regarding the temperature, we know that there are two types of reaction, exothermic reactions and endothermic reactions. Exothermic reactions means the heat is evolved and endothermic reactions means the heat is absorbed. And as we know, we are seen in our 11th standard topic chemical equilibrium. In that we have seen a Le Chatelier principle. If the system is at equilibrium and if we increase the temperature of that system, then the applied stress, it will be the increase in temperature. That means the equilibrium is disturbed by increasing temperature. Then at that time, the increase in temperature or the additional heat, it can be absorbed by that system according to the Le Chatelier principle. According to the Le Chatelier principle, that additional heat or additional amount of heat, it can be absorbed by that system, and therefore the increasing temperature favors the endothermic reaction. If the system is at equilibrium and if we add the some amount of heat and the equilibrium, it will be disturbed. That means the applied stress is the increase in temperature, and therefore the increase in temperature, it favors the endothermic reaction, and opposite to that, the decrease in temperature, it favors the exothermic reaction. The decrease in temperature means if the applied stress is the decrease in temperature, then the system adjusts itself in such a way that the applied stress, it will be minimized, it will be nullified, it tends to zero. And if at equilibrium, if we increase the heat, then system, it get absorbed, and therefore the reaction goes into the endothermic directions. And if we decrease the heat, then the system adjusts itself according to the Le Chatelier principle in such a way that the applied decrease in temperature, it can be increased by the evolution of heat, and therefore the decrease in temperature favors the endothermic reaction and the increase in temperature favors the exothermic reactions. But generally, the solubility of the solid in a liquid increases with increase in temperature. So this is the solubility of the solid solute in a liquid solvent. But instead of the solid solute, here we have considered the solubility of a gas in liquid. The solubility of a gaseous solute. If we consider the gaseous solute instead of a solid solute, then what is the solubility of a gas in a liquid? And therefore here the solubility of gases in water usually decreases with increase of temperature. The solubility of gases in a liquid decreases with increase in temperature. That means again, if we consider these two cases, then the solubility of a gas in either cold water is more or in a hot water is more, because usually the solubility of a gaseous solute in a liquid solvent, it gets decreases with the increase in temperature. That means if we compare both these cases, then the solubility of a gaseous solute, here instead of a solid solute, here we have taken a gaseous solute, then the solubility of this gaseous solute is more or its state increases in a cold water. In a cold water. And why it is so? Because from our topic states of matter, in that gaseous state we have seen one law called as a Charles law. It is all about the gaseous laws. And in that Charles law, and therefore according to the Charles law, here what we can say that V is directly proportional to T for the gas. The volume of a given mass of a gas is directly proportional to the temperature of that system of the gas. And therefore the solubility of the gaseous solute is less in this hot water. Why? Because here as the temperature increases, the volume of dissolved gas solute is also increases. As the temperature increases, the volume of mass of dissolved gas is also increases, and therefore the increased volume of the gaseous solute is not accommodated in this beaker, and therefore it can be escaped out from that beaker. Here usually we consider the oxygen gas. When we dissolve that oxygen gas in a hot water, then their solubility is very less. Because when we dissolve the gas in a liquid, then according to the Charles law, as the temperature increases, the volume of given mass of gas is also increases. Here the volume of gas molecules increases, and the increased volume is not accommodated in this beaker, and therefore it can be escaped out. It can be escaped out, and therefore as the temperature decreases, the gas molecules, they are dissolved in the water, and therefore there is one reason why the marine life like fish, they can be stay to preferred at a lower level than the upper level in the sea water. म्हणजेच तुम्ही जर बघत असाल तर सी वॉटर म्हणजे जे काही मराईन लाईफ आहे, they can be stay at a lower level than the upper level, because at the upper level the level of the gas, that means the oxygen, is very less. During summer season, due to the temperature, the upper leveled oxygen gas, it can be escaped out, because according to the Charles law, as the temperature increases, the volume of the dissolved mass of gas is also increases, and therefore the level of the oxygen is very less at the upper level, at the surface of the sea water, because the solubility of that gas is decreases with the increase in temperature at the upper level. And therefore there is a one reason, and a very important reason, that why the marine life, all the marine life like fishes and all, they can be stay to preferred at a lower level, because at the lower level the solvent is cold, and therefore it dissolves the more oxygen, because as we know the solubility of the gas in the liquid is decreases with increase in a temperature. Therefore during the summer season the gases, they are not present on the surface of the liquid, According to the Charles law, as the temperature increases, the volume of the dissolved gas is increases, and therefore the increased volume, it cannot be accommodated at that surface, and therefore it can be escaped out, it can be bubbled out, and therefore the marine life, they can be stay or they can be preferred to stay at a lower level. That is one of the reasons for the marine lives. So, according to that, this is the effect of a temperature on the solubility of a solid in a liquid and a gas in a liquid. So, the third factor is effect of pressure. What is the effect of a pressure on the solubility? As we know, the solid are incompressible. As we know, the solids are incompressible, and therefore pressure has no effect on the solubility of a solid in liquid, because the solids are incompressible. Therefore, if we apply the pressure on that solid, then there is no effect of the solubility of that solid in a liquid, because of the properties of the solids are incompressible. But there is a great influence or the great effect of the solubility of a gas in a liquid. There is a great effect of a solubility of a gas in a liquid, because of the property of a gas. As we know, the gases are highly compressible. The gases are highly compressible, and therefore there is no effect of a pressure on the solubility of a solid in liquid. The solubility of a solid in liquid with the factor pressure, it remains as it is, but the solubility of a gas in a liquid has a greater influence, has a greater effect, and the relationship between the solubility of a gas in a liquid is given by a law called as Henry's law. It is called as Henry's law, and it stated as the solubility of a gas in a liquid is the solubility of a gas in a liquid is given by the law called as Henry's law. Then, what is the statement of a Henry's law? It states that the solubility of a gas in a liquid is directly proportional to the pressure of the gas over the solution. The solubility of a gas in a liquid is directly proportional to the pressure above the solution. Therefore, here, according to the Henry's law, mathematically it is written as S is directly proportional to P. That means a solubility of gas in a liquid is directly proportional to the pressure of the solution on the gas. Pressure of the gas on the solution. So, this is the statement, or this is the mathematical statement of the Henry's law. Dear student, this question is very important for the 2 marks from the examination point of view. State and explain the Henry's law. So, what is the statement of a Henry's law? The solubility of a gas in a liquid is directly proportional to the pressure of the gas over the solution. The pressure of the gas over the solution. Mathematically, S is directly proportional to P. And if we remove the proportionality sign, then there is one constant called as a proportionality constant KH, which is equal to P. And here the KH is called as a proportionality constant, and it is in this Henry's law, and therefore it is called as a Henry's constant. It is called as a Henry's constant. So here the solubility, it is having unit as we know, mole per dm cube or mole per liter, and the pressure if it is taken in a unit of bar, then the kH, which is equal to here, the kH which is equal to here S upon P, the kH which is equal to here S upon P. If the solubility is expressed in mole per liter and the pressure in the bar, and therefore the kH, Henry's constant, which is equal to having given a mole per liter per bar, it is equal to mole per liter per bar. This is the unit of Henry's constant kH. So, dear student, here we can define the kH as, kH means the Henry's constant. kH means here the Henry's constant. kH is the, if the pressure is equal to 1 bar and kH which is equal to S. If we have taken a pressure of 1 bar here we have taken a pressure which is equal to 1 bar, means P is equal to 1, then at that time kH which is equal to S. That means the Henry's constant is defined as the solubility in mole per dm cube or liter when the pressure above the solution is equal to 1 bar. So this is the second and third factor which affects on the solubility. The second one is the effect of temperature, and as we know in general, as the temperature increases, then the solubility of a solid in liquid increases, but the solubility of a gas in the liquid decreases. This is our second factor. And in the third factor, effect of pressure, here the solubility is directly proportional to pressure, but the solubility of a gas in a liquid here we have to consider in this Henry's law. So this is a very important law that we have completed here in this today's module. So dear student, in this today's module, here we have completed all these factors which are affecting on the solubility. The first one is nature of solute and solvent. The second one is effect of temperature, and the third one is effect of pressure. So dear student, we will stop here. We will meet in the next module. Till then, stay home, stay safe. Thank you.